Well, welcome back, everybody. Okay, so today this will be the second part in our lecture 3 on sort of post-Smithian classical economics. And in the first section, first part of this lecture, we covered Thomas Malthus's theory of population. And in this part, we will discuss David Ricardo and the classical theory of rents. In the next part, we will cover the Ricardian steady state. So I know you can't wait for that one. I know. I can barely. No, it's cool, right? It's cool. This is interesting stuff. So this is David Ricardo, classical theory of rents. It's one of the earliest attempts at formally modeling economic ideas. By formal modeling, I mean putting numbers to it, testing it for logical coherence, and it's also quite basic, right? And so it's really a good way to start to learn and to think about hypothesis construction, about testing for consistencies, for building the groundwork for empirical work as well. This is not an empirical work, but it helps us to build the groundwork for that. And also, what really models are for, right? So it's a nice, really a basic entry into a lot of super important skill sets for an economist or even somebody doing this sort of work to have. Okay, so this is going to be a pretty short presentation, and I'm going to buzz through things pretty quickly. This is meant to be one of the more technical presentations. The next one on Ricardo will be a little more broader and sort of philosophical and so on. Okay, so here's what we're going to assume, and here's what we're going to take as given, right? So the first items here, right over there. Okay, I'll use the cursor as well. These are our assumptions of this model. So we're assuming that returns from land diminish. So as we try to get more and more yield out of a given unit of land, those yields will fall. Okay. We're also going to assume that there are different gradations of land. Right? So some land that is just better to start off with, and other land that's not as well off. We're going to assume that labor and capital are purchased together in one unit. So to continue our agricultural example, we might be saying, this is farmers with shovels. So farmers, labor, shovels, capital are purchased together as a single unit. Now, there's actually something really clever that Ricardo is doing here. So it seems like kind of a hokey thing to do, right? But it's actually quite clever what Ricardo is doing. And when we come back with Marx, some time from now, so we'll be studying Marx later in this term, we're going to really see, it's going to become super clear like why Ricardo does this here. For now, know that when constructing economic models, it sometimes makes sense to combine variables that we aren't super interested about the specific results. For example, the research question here is not what determines wages. The research question here is, why is some land more expensive than other land? Okay, we don't really care what the rate of interest is. We don't really care what the wage rate is. And so Ricardo combines these for what it ends up being is mathematical expediency. So just kind of keep that in the back of your mind. But that's an assumption we're making here. Okay, the cost of labor and capital is constant. So basically I can buy as many farmers with shovels as I want at a fixed price. And then the last thing, and this is the classic theory of rents, is that rent payment is a residual after L and K are paid. So it's kind of like savings in a Keynesian macro model, meaning that, so I'm Farmer Joe, right, and the crop yields X amount of corn, and the revenue received from that corn is, say, $1,000 or something like that. Well, I'm going to pay my workers, I'm going to pay my capital, and let's say that comes to $900. Well, Then the remainder rent is what I pay in rent. Okay, $100. 1,000 minus 900. Residual 100 becomes the rent payment. And that's how classical economists, Smith has a couple sort of stories, right, in Wealth of Nations, but that's pretty much how classical economists up to Marx looked at land rental payments. And we've talked a little bit about that in lecture 0 on pre-Smithian economic thought, about why that is. I'm not going to go too much into that again here. Suffice it to say that you can find the origins of those ideas in physiocratic thought and leave it there. Probably another YouTube video better than anything I've ever done on the physiocrats. I don't know. I never looked. Okay. So givens, we're also going to assume that each and every unit of labor and capital costs 140. This is what your text does. So for those of you who aren't in the class, this is Mark Blaug's Economic Theory in Retrospect, which if you're at all interested in history of economic ideas, that is the book. Okay, right? So it has absolutely my highest recommendation. It's not exciting. It's not a page turner. But boy, if you want to know the history of economic thought, that is the book. Okay. Again, Mark Blaug's Theory in Economic Thought in Retrospect, and you can find all this in the chapter on classical theory of rent. All right. The market price of output is one per unit, right? So every bushel of corn or whatever it is, bushel of wheat is 1 unit or $1. Okay, that's just to keep the math simple. We're going to take that there are different qualities of land. In particular, we're going to say there's 5 different qualities of land. The best land is A land, B land, C land, D land, and the worst land is the E land. The worst land that's cultivated. There may be an F land or G land, but for reasons that we'll see in just a moment, those lands would not be cultivated. They would not be farmed. And then finally, it's not on my list here, but it's important to understand that the idea of opportunity cost is not a part of the classical theory of rents. Okay, so we're assuming that this land, A through E or A through whatever, can only be utilized for agriculture. It cannot, in class somebody say, well, what if they build condos on the land, right? Okay, you can't, which is great, right? That's perfect. That's exactly the type of questions a good student should ask. This does not, there's nothing like that, right? So there's no sort of opportunity cost of letting fields or of cultivating fields. There's no gain to be had by letting fields lie fallow. All right, so let's continue. No tax write-offs for it either. All right, so over here now we have these are just some numbers that follow through from the assumptions on the previous slide, as well as just somewhat arbitrary. Okay. These numbers are consistent with all of our assumptions, so any numbers that would be consistent with those assumptions would work fine and would yield similar results. Okay, so on the far left-hand side of this table here, these are units of capital and labor. So these are the results if we hire no capital and labor. These are results if we hire 1 unit of capital labor. These are the results of 2, 3, 4, and 5. Okay, you got it. All right. This column here is A land, B land, C land, D land, E land, similar. A land, B land, C, D, E. Okay. Total product and marginal product, not going to review those concepts. If you're not familiar with those ideas, please review any basic 100 level microeconomics material. Just Google like total product, marginal product. Okay. Again, I'm sure there are truckloads of awesome videos on that. All right. So we're going to say that, of course, if I add 0 capital and labor to any of these lands, they yield nothing, because this is an important part of the sort of classical theory of rents. It is land in itself is not productive. Land is only productive when people contribute to it, or somehow capital and labor contributes to it, right? And so land in itself does nothing and produces 0 output. But when we add 1 unit of labor to any of these 5 units of land, we get some output. Now, the easiest way to understand what's going on here is to actually work from right to left. So we're going to start with this E column here in our explanation. So let us say that the E column of land, the least productive land being cultivated, produces 140 in output when we add 1 unit of labor and capital to it. Okay, remember now that the cost of that labor and capital was 140. So the product of the land is exactly equal to the cost of cultivation, 140 in both cases. Any land less productive than land E will not be cultivated because its yield will be less than 140, which will be its cost of cultivation. In other words, the farmer's going to lose money if they try to grow stuff on lands beyond worse than E. Okay, so that is actually most of the story. Let's see what happens though as we walk back to the D and C and so on land. Going back to the D land, because we assume that land is exhibiting diminishing returns, we know that the marginal product on the E land, or excuse me, the D land is going to be greater than the E land, just based on our assumptions, right? The numbers have to be that way or they violate our assumptions. All right, so let's say we add 1 unit of capital and labor to the D land. We get 150 in product, and what did it cost us to cultivate that land? 140. Okay, so it makes sense to cultivate the land. What if we add a second unit of capital and labor to the D land? Well, we find that we get another 140. So the first unit we got 150 out, the second unit we get 140 out, diminishing returns, right? Okay. So we get, when we add 2 units of capital labor, so 2 farmers with 2 shovels, we get 290 in output from the D land. Okay. And what did it cost us to cultivate the D land? Well, 140 times 2 units added, or 280. Okay. So the difference then is between the product, 290, and the cost of cultivation, 280, is 10. The rent on the D land is 10. Okay, so the rent is the residual of the product minus the costs of the other factors utilized in production. Now, you'll notice that land is getting $10 that it itself, at least in the classical theory of rents, didn't contribute anything to, right? If you had no capital and labor, the value would have been 0. Okay. So remember that idea because it's central to the idea of rent, not just in this theory, but when we talk about rents in general in economics, right? Rent in general in economics is an unearned increment. Okay, so here's where we see the origin of that term. Okay, on the C land, similar, right? We add 1 unit of capital and labor, we get 160 a product out of that. Why? Because it's better land, right? Okay. We add a second unit of capital labor, we get 310. I'm following through this column right here. We get 310. What's the cost? 280. Okay. We add a third unit of capital labor, a third farm. Man, this land's growing so much corn, we can hire a bunch of workers, and they have so many corn there, they spend all day picking corn. Yeah, I know it's a super simple model, right? Okay. All right, so we add 3 units of 3 farmers with shovels, and we get 450. Well, what's the cost to cultivate? 140 times 3. 140 plus 140 plus 140, or 420. Okay, difference between product, 450, and cultivation cost, 420, is 30. Rent on land C, 30. Okay, and we keep going backwards, and we keep working the same process. The A land, the rent is 100. Okay, take a look at that here on the next slide. So here we have the costs of production on E through A lands, and we have the cultivation costs on land E through A, right? The first 3 we did. The second 2 I would expect people to be able to work out. Okay, and so this is our classical theory of rents, right? The research problem was, for David Ricardo as well as other economists working on this problem at the same time, why is some land more expensive than others? Okay, it may seem a trivial question, but remember this is 1810. Okay, remember that there's no Zillow.com. In 1810, there's no real estate data in general in 1810, right? And so the research question being put forward is, why is this land more expensive than others? And the working hypothesis is, well, some land's better than other lands. And we're going to assume that, as you keep trying to farm more and more off a given land, you get less and less out of it. What rate does it decline at? I don't know. Let's just say it declines, right? And then it's an empirical problem beyond that. Let's say, okay, well, there's some land's better than others, okay? So from that working hypothesis, we develop some assumptions that we think are reasonable. Those assumptions are the ones given on the first slide. Okay, this is what these economists are doing. They've got a research problem, they have a working hypothesis, they develop a set of assumptions, and then they're going to logically derive mathematical results. So they're going to take those assumptions, they're going to plug in numbers that are consistent with those assumptions, and then see, do the mathematical results correspond to observed reality? Well, indeed, if we assume these things, right, then indeed we get, a bunch of different rents, right? Some land's expensive, some land's cheap, and other land's in between. Okay. And so what we have is a tentative acceptance of our hypothesis. The classical theory of rents, to the extent that we've done so far, corresponds with a set of observed prices. Okay, so this is extremely rudimentary modeling and hypothesis testing. You might say, like, geez, there's no data in here or anything, they didn't go out and look at yeah, they didn't, right? All they have right now is internal logical consistency, right? That's what these simple models do. And indeed, advanced empirical models like we use today in economics in 2020, they were in their infancy just 30, 40 years ago, right? So modern statistical techniques, modern data availability has radically transformed model construction and how we do economics. But those can be tricky to kind of get into at the entry level, whereas these models, it's very straightforward to see what we've done here. It's very straightforward to see the strength in our results. This is clearly better than nothing, right? I mean, you could take a lot of things that people say, like, why do you think this is, person? And then they say a thing, right? And then you try to do even the most simple logical test of it, and it fails completely, right? Here, at least, we're trying to see whether our explanation exhibits some kind of logical consistency. And that's a really good first step, right? It's a really good first step when you're doing science. And so, being able to work through this Ricardian model, one, teaches a little bit about introducing some rigor into economic thinking, and it also teaches a little bit about how we construct models and why we're constructing them, right? And what makes for a good model and maybe not such a good model. So that's enough for today. We'll leave it there. I hope you learned something, and we'll see you again next time. Take care. Bye.